Hi everyone, and welcome to another Oilfield Technology Spotlight. My name is Nicholas Woodruff, and I'm the Deputy Editor of Oilfield Technology magazine. Today, I'm joined by Adam Calvin from Tetra Technologies. Our discussion will be based upon an article written by Adam that was published in the magazine's first issue of 2021, entitled Innovating Against the Grain. The article takes a look at sand recovery challenges and new technology that is emerging in response to these challenges. If you haven't had a chance to read Adam's article already, it can be read for free on our website at oilfieldtechnology.com/magazine. So Adam, welcome to this Oilfield Technology Spotlight. Thanks so much for joining me.
Thanks for having me, Nick.
So to get us started, do you think you could introduce yourself to our audience?
Absolutely. I manage our Central United States production testing and fluids business, primarily dealing with business development, technology development, and operations. I've been with the company about 8 years now. I've held various roles, started out in the field, worked my way into management. I've held management positions with all of our different product lines, from water management to production testing and completion fluids.
Perfect. Thanks so much, Adam. Okay, so to set the scene, could you explain why more efficient sand management is needed?
Yeah, so the problem is really twofold. Recently, completion design has changed from larger proppants, whether it be 2040 or larger, down to a 100 mesh proppant. So 100 mesh proppant is about 149 microns. So, the frac sand that's going down is significantly smaller than the sands that have been used in the past. As well, a lot of operators and completions are using in-basin sands. So they're literally just scooping up sand off the ground, pumping that down hole. Again, it starts off at 149 micron. However, this in-basin sand has a higher tendency to crush to a much smaller grain. And so when that sand flows back, or when that well flows back, there's much more issues trying to capture that smaller proppant.
Right, so there are clearly challenges that need addressing here. So before the introduction of the Tetra Samsung technology, what were operators using to combat these issues?
So there were a number of systems. Probably cyclonic sand traps were the most common, and really all that was a vessel that was designed to slow down those fluids and utilize gravity to drop them out. They had some offset inlets that created a circular motion, which was intended to sling those particles to the inside diameter of the vessel. Those particles would then settle to the bottom, where the solid free fluids would exit the top. And the issue is that they weren't sized properly for the types of velocities that we were seeing and the size particles that they were trying to separate. And so these hunter mesh particles and this crush hunter mesh are just passing right through them. And so what was happening was you were just installing more and more equipment. So instead of running one sand trap, you'd run two sand traps. Sometimes you'd run even very large diameter multi-phase vessels to try and really just slow that fluid down and give gravity enough time to work on those solids. So it was more equipment, more personnel was you know, the the solution prior to some of the efficient sand management, which we're about to discuss.
Sure, so from your perspective, what makes it different from other technologies on the market that claim to be 90% or more efficient?
Yeah, so again, a lot of these technologies on the market are claiming to be highly efficient at that 149 micron range, which is very difficult to do. However, they don't do a lot to combat the crush proppants. So the sandstorm is designed not only to be efficient at that 149 micron range, but also those smaller crush proppants. And what differentiates it is that we've actually designed it to be efficient and to have the necessary velocities and the forces at the velocities and the flow rates that we expect to see in the different basins. We're actually looking at it, we're designing it based on calculations that these forces will remove these solids at these flow rates. And so that type of design is not a cyclonic, it's called a hydrocyclone.
So following on from that, do you think you could tell our audience how the system works?
So it's very much a function of velocity. The particles and all the fluid really is conditioned to go into a vortex, and so it works on centrifugal force. Those particles are separated from the flow stream by centrifugal force, and then those particles fall down into the vessel, whereas the solid free fluid exits the top. Similar to a cyclonic, however, this again has been sized properly to where it's imparting the forces required to remove the solid.
So could you outline the economic benefits that a customer would get from using the sandstorm?
Sure. First and foremost, and probably the most notable, would be the reduction in equipment. As I mentioned before, the solution was just to add more and more equipment, which required more and more labor. And with the sandstorm, we can capture 97 to 100% of all the solids in the flow stream in a single pass. And so you can now eliminate that downstream equipment, eliminate that incremental personnel. That equipment was out there to protect the production facilities from filling up, needing remediation as far as removing those solids from the tanks and the separators at the production facility. Those sands were, common and typically would wash out flow line and pump seals, and with the sandstorm, none of that happens.
What are the flow ranges that the sandstorm is capable of being efficient at?
So we have several different inserts. The system is modular, and so we can efficiently separate sand at 1,000 barrels per day, all the way up to over 30,000 barrels per day.
Staying on the topic of efficiency, is the sandstorm's efficiency affected by oil, gas, or water ratios?
So solid separation out of a flow stream is certainly dependent on the fluid's viscosity, and so it's easier to separate sand out of gas than it is water, and furthermore, it's easier to separate sand out of water than oil. But we've modeled the efficiencies based on the worst case scenario, and so really it doesn't matter what your oil gas water ratio is. We've modeled and designed the unit to be efficient in the most extreme scenarios.
Okay, is the efficiency affected by pressure? And what are the pressure ratings of this equipment?
Yeah, so the efficiencies aren't necessarily affected by pressure. However, pressure can have an effect on the fluid's velocity. Obviously, gas decompresses as pressure drops, and so those velocities increase, which typically, or will always, will result in a more efficient hydrocyclone. Currently, we have a variant in 5,000 pound, 10,000 pound, and 15,000 pound operating pressures.
Great, thanks for giving us such a detailed overview into the sandstorm system, Adam. What's next in the way of technology development at Tetra Technologies?
So we at Tetra feel that we have designed a very capable system at removing solids from the flow stream. However, even before that, we identified that, with the introduction of 100 mesh and this crushed 100 mesh coming back, that sand production in these basins is lasting much longer than recent completion designs. And so the labor component is very significant. And so even if you design a system that's capable of removing all the solids, you still have personnel operating those systems for very long extended periods. And so Tetra set out to automate the dumping of these sand traps. They accumulate solids over time and still need to be dumped and flushed clean. And currently, the method for doing that is on-site personnel. So we've developed systems that can automatically remove the solids from these sand traps safely. We've layered in the different redundancies and safety systems that would be required to run these automated systems. The development is in its infancy, but in the future, I expect you'll see more and more of that.
Yeah, definitely something to keep an eye on there. Before I wrap things up, do you have any final thoughts or closing comments you'd like to make, Adam?
So, Tetra Technologies, we like to say that we're a technology company and not just an energy service company. We have a lot of differentiating technology, whether it be on the flowback side or our water management side. And majority of this technology has been developed as a result of a customer coming to us with an issue, and our engineering team sitting down and scratching their heads, throwing stuff on the whiteboard, and going through the product development stage. So I would just encourage anybody listening that if you have a problem, whether it be the problem we've outlined here today or a problem that you can't find a solution for, to reach out to us. We're constantly looking for our next challenge.
Excellent. Adam, thanks so much for sharing your time with us today and letting us dig deeper into your article.
Thank you.
And before we finish today, I'd like to remind everyone watching that you can read Adam's article in full for free on our website by following the link that's appearing on your screen now. Thanks for watching, and I look forward to seeing you next time.